Hello everyone, my name is Apoorv Bapat. I welcome you all in ELEATION's ANSYS Basic to Professional Training Program. In session 7, we'll see how to solve fixed 1D beam element problem using ANSYS workbench. So we'll start with recap. In session 6, we have learned how to solve 1D beam problem subjected to bending load in ANSYS workbench. And in session 7, that is today, we'll learn how to solve fixed beam 1D problem using ANSYS workbench. So we'll going to solve this problem where we are going to apply constraint at both the ends and apply load at the center of the line using circular cross section. So first we will see the analytical solutions of stresses and deformation. So analytically the maximum stress is coming as 38.19 Newton per mm square and deformation is coming as 0.16 mm. So again today I am going to show you all these steps and then we'll perform all these steps in ANSYS workbench. So we'll open ANSYS workbench, select static structural, open engineering data and check whether the structural steel is assigned or not. Click on geometry and open design modeler. Create a sketch, convert the sketch into line body, create circular cross section, we'll link it to the line body, we'll open mechanical, generate the mesh, apply bending force at the center, apply fixed support at two ends, define output, solve the file and view the results. So we'll start with opening ANSYS workbench. So this is the GUI of ANSYS workbench. So I will double click on static structural to open static structural in project schematic. Double click on engineering data. To check whether structural steel is assigned or not. So you can see the structural steel is assigned in my library. So I'll go back to my project schematic view. So I will close this from here at the top. And then I will right click on geometry and select new design modeler geometry. Once I click new design modeler geometry, at the bottom it will show that opening or starting design modeler. So we'll wait for some time till it opens design modeler. So now you can see it has opened design modeler and right now the units are in meters. So first we will change the units to millimeter. So I will change the units to millimeter. Now you can see my unit has changed to millimeter. Now to create the sketch, first I will select the plane. So I will select XY plane, right click on it and say look at. Now I will go to sketching option here. In sketching option under draw you will find lines. So I will click on line, left click on GUI and create the first line. Now, in this problem statement, I have to apply load at the center. So if I want to apply load at the center, then I should have a point at the center on which I can apply load. So that's why I will create two lines, that is line 1 and line 2. So I will create two sketches. One is of length 500 mm, the other one is of length 500 mm. So the total length be 1000. I can also create a single line and I can use nodes to apply force at the center. In the next problem, in the next session, I am going to show you how you can apply forces on nodes via creating the single line. Today we are going to see how to create two lines which are connected to each other and apply the force at the center point of the line. So I have created first line, then again I will click on line. Once you move your cursor on line, you can see a C symbol on the line. Once you move the cursor at the edge or point of first line, you can see the cursor changes to P. So once it's showing P, that means the second sketch which is going to create is connected to first sketch. So click on there and create the second sketch. So I have created two sketches. Now I will give the dimensions as 500, 500. So the total length will be 1000. So under dimensions, I will click on general. I will select first sketch and second sketch and then I will give the dimensions as 500 and 500. So I will enter 500 here and 500 here. So my entire length of the sketch becomes 1000. It has moved out of screen, so you can bring it to fit to screen by pressing on this button or clicking on F7 from the keyboard. So now my sketch of total length 1000 with two different sketches of 500 is ready. So now I will go back to model and then convert this. Right now as I have only 0.0 body, so I will convert this sketch to line body. So to convert the sketch into line body, I will go to concept, lines from sketches. Now either you can select these two sketches by pressing Ctrl, or else you can click on this plus symbol and then you can simply click on this sketch, the sketch what you have created earlier. Once you select the sketch, it will select both the sketches and then click on apply. So here you can see one sketch has been selected. Once it's done, then click on generate to execute the process. Once the process is executed, you can see under one part, one body, you can see a line body. Again, this line body will not have a cross section, so I will create a cross section. So to create a cross section, I will go to concept. In concept, I will select cross section and I will select circular. So as per my problem statement, a dia is 100, so I will give radius as 50. Again, I will click on fit to screen. Now I have to assign this cross section to the line body, so I will click on line body and double click on not selected. So while cross section is assigned, I can also view how the cross section will look under cross section solid. So from here you can see I have two separate line bodies which are connected to each other with a circular cross section. So with this, everything related to design modeler is completed. So now I'll again go back to workbench from this icon and double click on model to open mechanical. Once you double click on this model, at the bottom you can see it is showing starting mechanical. In earlier sessions I have already shown you how to change these colors. So I will go to geometry, my structural steel is already assigned, so I will directly right click on mesh and say generate mesh. So it will create elements. Now again I will right click on static structural, insert fix support. Right now it's showing the mesh view, so click on this icon to change the view from mesh view to line view. Then click on this icon to select the points option on. Select the first point, press Ctrl and select the second point. So from keyboard, if you press Ctrl, you can select both the points and say apply. So my software has applied constraints on both the locations. Now I'll apply forces. So to apply forces, right click on static structural, insert force. Again I will click on this icon. I will select the center point. I will select the center point and then I will click on apply. So the vertex has been selected. I will double click on vector to change it to component. And in minus y-axis, I will apply a force of, in y-axis, I will apply a force of minus 30,000. So if I click on static structural, here, I can see where are the constraints and where are the forces. Then I will right click on solution, insert deformation total. Again I will right click on solution, insert beam tool, beam tool. So I have defined the output for deformation and I have defined output for deformation and I have defined output for stresses. So once you have defined the output, then click on solve. So at the bottom you can see a solver window will come. So once it's solved, it will check the box in front of total deformation. So click on total deformation to see the value of total deformation. It's coming as 1.17, and then click on minimum combined and maximum combined stresses to see the values of compressive stresses and tensile stresses. Even you can animate to see how this deformation will come. So with this we have solved the problem, and these are the results of stresses and deformation. Before we go ahead, let's see the homework for this session. So we have first problem using structural steel square cross section, aluminum alloy circular cross section, titanium alloy hollow cross section, stainless steel hollow circular cross section, C section with grey cast iron, I section with magnesium alloy, Z section with copper alloy, titanium alloy with L section, aluminum alloy with P section, and copper alloy with H section. So total 10 problems we have for fixed beam using 1D element. So with this we have completed session 7. Thank you for attending session 7. In session 8 we are going to cover how to solve simply supported 1D beam problem using ANSYS workbench. If you have any queries or any doubts, feel free to contact us via query@eleation.com, or you can visit www.eleation.com.